So let's review the two methods we have on sampling a known PDF function. So this is assuming we are sampling not based on data, but based on a PDF or CDF that comes out of modeling the data, which is very often the case if you look at tails, because we almost never have sufficiently many samples to actually sample directly the data to model the tails. So this is an illustration of the CDF-based sampling methods, also known as the inverse mapping method. So we sample uniformly on the y-axis and map it according to the inverse of the cumulative density function or cumulative distribution function. The shallower the CDF is, the more we are kind of widening or spreading out the samples, the x-axis, therefore having a lower density. The steeper the slope is, the more we are concentrating the samples in the x-axis, and thereby having a denser samples, a higher probability over that region. So that's actually one of the most handy methods of sampling power law distributions, right? Because we can, from the tail, we can integrate the PDF exactly, because integrating a power law function is pretty easy. And the inverse of a power law is also not a huge problem. Another way we learn how to perform sampling is PDF-based sampling method. And here, we want to talk a little bit more about that, is that you can actually combine these two methods. So imagine if you have the PDF of a method that is very hard to transform into a CDF. But it is also not very suitable for acceptance rejection based method out of a uniform distribution. So that is often the scenario. For example, if your distribution goes all the way to infinity, right? If you have a distribution that is infinitely wide, then you can't have a uniform distribution that kind of dominates that all the time. So a commonly used approach is to come up with a distribution. Here is the distribution of y that follows more or less the same trend as the distribution of z, which we want to sample. For example, this actually distribution of y actually goes to infinity. But also, when you scale it up, scale the PDF of y by a finite factor, the PDF of y actually dominates the PDF of z, which we want to sample. Then you apply first of all, you apply the transformation method to get a set of samples for y. And then after you have a set of samples for y, you can apply the acceptance rejection method. How do you do that? Now can somebody tell me, if I have this plot of the two PDF, what is the ratio of acceptance at a particular sample of y?
It's similar to our previous uniform distribution, but it's a sample from the uniform, you're sampling from the histogram of y.
I'm sampling from the histogram of y through an inverse CDF method, right? But then, what is the probability I'm going to accept the particular sample to give me a distribution of z? It's actually, yeah, the ratio of the height between the blue and red histograms. And the procedure is the same. For every sample of y, I'm going to sample yet another independent random variable. Let's call it x. And the base x is going to be uniform. And I'm going to accept or reject that particular sample of y based on the value of x less than this ratio or greater than that ratio. right? So then I'm gonna get a histogram of Z, which I want to sample.